and into railway cars which convey the ore to the loading dock. Arriving at the loading dock, the ore is dumped into pockets for transfer to Great Lakes freighters. The average loading time is about 6 hours. The average load about 10,000 tons. Great limestone deposits that millions of years ago were the bed of an inland sea give up the second basic material used in modern steel making, limestone. The entire wall of the quarry has been shattered by blasting to permit removal of dense, hard material. An electric shovel swings into action. These cars are carrying 600 tons of calcium carbonate, or stone as it's termed in the industry. With the push of a lever, a carload of stone is dumped. Plunging into a huge crusher of cast steel, the complete unit weighs 750,000 pounds. The crushed stone is deposited in huge storage piles, 60 feet high and several hundred feet long. Beneath the storage piles are underground tunnels through which the stone is conveyed to the loading shuttle, which carries 2,500 tons per hour. After hundreds of miles of open water travel, cargoes of iron ore, coal, and limestone arrive at the steel plant and are quickly unloaded. Speed is essential to get the boats away quickly for another load. Trainloads of the third basic material, bituminous or soft coal, arrive at the plant where it's converted into coke. This takes the place of the charcoal previously used as fuel. After the coal has been crushed, it's heated in these huge ovens until the moisture and the volatile matter have been driven off. After various byproducts have been extracted from the volatile matter, the gas remaining is used as fuel. After 16 to 24 hours, the red-hot coke is pushed out. It's now 91 to 92% carbon. The first step in making steel takes place in the blast furnace. Here the oxygen and impurities are removed from the ore and the iron reduced to a liquid. Up to the top of the blast furnace go skips with accurately weighed loads of iron ore, coke, limestone, up and down continuously, for one of these giants eats up 3,500 tons of raw materials a day. Making 1 ton of iron requires approximately 2 tons of iron ore, 1 ton of coke, half a ton of limestone, and 4 tons of air. The blast of cold air of the ancient iron maker is now replaced by these huge hot blast stoves and powerful blowers which force huge amounts of preheated air into the furnace. Heating the air increases production and decreases fuel consumption. In striking contrast to primitive methods, modern blast furnaces are scientifically controlled. With the blast furnace in operation, let's see what takes place inside. Up through the mass of coke, iron ore, and limestone is blown a roaring blast of preheated air. At the top, the temperature is about 300 degrees Fahrenheit, increasing at lower levels to a maximum of about 3,300 degrees. As the charge heats, gases formed by the burning coke draw oxygen from the ore as it descends through the furnace, leaving spongy metal similar to that produced by primitive methods. The charge descends through increasing heat until at about 2,000 degrees, the spongy metal absorbs about 3.5% of carbon from the coke. Continuing to descend at about 2,500 degrees, the iron with the absorbed carbon melts. The limestone combines with the earthy matter of the ore, forming slag. The iron and the slag form in molten globules like raindrops, which trickle down through the burning coke. A pool of molten iron is formed on the bottom of the hearth. The slag floats on the iron and is drawn off from time to time. Every 4 or 5 hours, the tapping hole is opened, and out rushes a glowing stream of molten iron, termed in the industry hot metal. Sometimes this hot metal is poured into molds, and the resulting pig iron shipped to foundries for castings. But usually the fiery river pours through channels which lead it over the tapping floor to huge ladles which hold 125 to 150 tons of hot metal. But before this becomes steel, it must be further refined. So let's take a look at the open hearth department. 90% of all steel today is produced in the open hearth furnaces because of the demand for tailor-made steel in large quantities, which can be produced with this flexible and efficient method. The nearly human charging machine dumps a box of limestone into the furnace and withdraws for another load. The limestone removes impurities from the steel. In similar manner, the furnace is charged with a predetermined amount of scrap metal. As the scrap is already refined steel, it's a helpful ingredient. Lastly, a giant overhead crane brings a huge ladle of hot metal as it comes from the blast furnace. The usual charge is about half scrap steel and half blast furnace iron. An open hearth furnace consists of what might be termed an upstairs and a downstairs. Upstairs is the hearth, in which the steel-making materials are refined. Downstairs are heating chambers containing fire brick, laid in checkerboard pattern. One chamber for heating the fuel, which may be oil, gas, or oil and tar, and another chamber for heating air. The preheated air and fuel move upward, pass into the space above the hearth. Combustion instantly takes place. Currents of flaming fuel sweep over the hot metal, creating temperatures as high as 3,000 degrees. Excess carbon and impurities are burned out. The hot exhaust gases pass down through another set of checker chambers, heating the bricks as they pass between them. Every 15 minutes, the direction of flow of the fuel and air is reversed. In this way, air and gas are heated in one set of chambers, while hot exhaust gases are heating the others. This operation continues for 9 to 12 hours. In the door of the furnace is a peephole through which the melter in charge observes the heat. Let's borrow his colored glasses and peer inside at the boiling, bubbling steel. From time to time, samples are taken for laboratory analysis. To make sure the steel meets the rigid requirements, tests accompany every step in the production of the steel. This is the other side of the open hearth. The heat is completed, and the metal is being tapped, poured into ladles. Higher and higher it mounts until the slag, being lighter than the molten steel, rises to the top like froth and overflows. A giant electric crane, with the greatest of ease, picks up the huge ladle containing some 100 tons, 200,000 pounds of molten steel. The hot metal is poured into molds, a process called teaming. After the hot metal has had time to settle and partly cool and solidify, the mold is stripped off, and we have what's called an ingot. The size and shape depend upon the kind of finished steel to be made. The ingot is placed in a hot furnace called a soaking pit, where it remains until it's of uniform temperature throughout. Here comes our ingot from the soaking pit, a 23,000-pound block of steel starting through a series of operations that will gradually shape it into a form suitable for manufacture into finished steel. As the first step, it is rolled into a rectangular slab. Heavy rolls grip the hot steel and pull it through as a clothes wringer pulls wet clothes. A highly skilled roller from his pulpit, as it's called, handles the operations. After reduction to the desired thickness, a portion of what was the top of the ingot is cut off. This is discarded to assure the elimination of possible defects. Then it's cut into slabs of the desired length. After reheating, the slabs pass through rolls which loosen the scale formed during the reheating. Then they go through 4 sets of rolls termed roughing stands. With each pass, the hot steel gets thinner and longer. It emerges from the last roughing stand in the form of a long strip approximately 3/4 of an inch thick and passes then through another scale breaker and into the finishing stands. Monster machines, marvels of mechanical ingenuity. The total weight of each is well over 1 million pounds. Emerging from the last finishing stand at a speed of about 1,250 feet per minute, the hot rolling process is completed.